Hi, and now we are on lesson 5, section 2.5 of chapter 2. It's a very, very hot day today when I'm taping this, so please excuse me if my brain is not completely engaged. It's Thursday and it's 33 degrees. Okie dokie. Right, this lesson is on sketching y is the modulus of the whole function and y is f of the modulus of the x. Now, we've already looked at this one in section 1 of chapter 2, and this is new to you. So this is today's lesson. Write that in your books. Right, so let's just remind ourselves of how we would sketch f of x and the modulus of f of x. Right, so here's your original function, f of x. So we can see we've got a cubic, a positive cubic. Now, what happens is if I want to sketch the modulus of f of x, that means everything that is negative, all my negative y values. Now my negative y values are here, yeah, and here. All my negative y values now become positive. That's what the modulus sign means. So what happens is all the positive y values will stay the same. So this stays the same because positive y values is the graph, everything above the x-axis, and all my negative y values will now become positive. And what happens is they reflect about the line y equals 0, or about the x-axis. Okay, so the key was sketching the modulus of the whole of f of x is everything beneath the x-axis is reflected about the x-axis. So my whole graph is positive. Right, now how does that change if I'm asked to sketch this? Okay. Now, a subtle difference here. The modulus sign is now just of the x, not of the whole thing. So what this is saying is if I just look at all my positive x values, all of these positive x values, yeah, f of positive x, if I look at the modulus of it, it will be exactly the same. Yeah. Now, what happens for my negative x values? Okay, so my negative x values, -1, -2, all of these are this side of the y-axis, my negative x values. Well, they are now, because so I've got f of a negative number, yeah, so f of a negative x. When I take the modulus of it, it becomes the same as f of x, i.e. f of -1 will become f of 1. F of -2 will become f of 2. So what happens is that all the values this side will just take exactly the same values as they were on the right hand side. So I ignore all of this, and so what will happen is in my graph, this will stay the same, going through -6 and 3, and then it's reflected about the other side. So this will be f of the modulus of x. So the difference between these two types of graphs, these two here, is this one, everything beneath the x-axis is reflected on the x-axis, and here you ignore everything for negative x, because the negative x values will take the same as the positive x values. So it's a reflection about the y-axis. Okay, so get those two examples in your book, really important. Okay, let's look at another example. This one here. Okay, so you're asked to sketch y equals the modulus of the whole function x, first of all. So everything above the x-axis will stay the same. Now this graph here is tending towards the x-axis, so I've got an asymptote here, but it doesn't actually quite touch it. Now everything beneath the x-axis will reflect above the x-axis, so I get this. Okay, so the pink, or this orangey pink colour, is now the solution. Okay, let's look at if we were asked to plot f of the modulus of my x values. I ignore, so I'm just going to draw this graph again. I keep all my positive x values the same, goes through 2 and 10. I ignore all my negative x values, and then it's just a reflection about the line, and I'll go through -2, about the y-axis. So this is my answer here for f of the modulus of x. Okay. I'm just going to check this is still taping, guys. Sometimes my video stops. Yep, that's fine. So, let's try, I want you to try this one. Okay? So you're going to try sketching these two for this graph. So pause the video, have a go, and I'll go through both the answers. Okay, so let's look at A. Let's see how well you did here. Y equals f of the modulus of x. So, the graph will stay the same for my positive x values, and then it reflects about the y-axis for my negative x values. Okay? And part B, everything above the x-axis will stay the same, and then this part will flip on the x-axis. So there's my values. So y equals f of x, the modulus of it all. So this is showing that everything is positive for my y, for all values of x. Okay, and it's knowing the difference between the two, understanding what they mean. Right, let's look at this one. So try this one, pause the video, have a chance to do it, and then I'll go through the answers once you've had time to do it. Okay, so let's look at the first one, the modulus of the whole thing. Okay, so the modulus of the whole thing, everything above the x-axis will stay the same. I might just draw it on here. Yeah, this will all stay the same. So this will all stay the same. That's 5, 3, -6, 4. And everything beneath the x-axis will flip. So this is the end answer. Okay, so you can see I've only got positive y values for all values of x. My graph has no negative y values. And if I wanted to plot now f of the modulus of x, what happens? Everything stays the same for my positive x values. Okay, so that's 4, 3, 5, and then it flips about the y axis. That's my answer. Okay. Now, this is another example where you're given the formula now, not the sketch. Okay. So we're going to have to first of all sketch f of x and then sketch these two modulus functions. Right, so to sketch this, I'm hoping it will factorise. Let's just see if it does. So 12 will be 6 and 2. I want 6 to be negative and 2 to be positive. Yeah? Okay, so if I was to sketch my function of x, I've got a quadratic, I've got a positive happy quadratic, and it will go through -2 and 6, and when x is nothing, it goes through -12 here. And the minimum will be halfway between 6 and -2. Yeah, so about 2. Yeah, it'd be 2 here for x. So it's not here the minimum, it's here. Okay, so this is my function of x. So you can see x is 6 and x is 2 is where it crosses the x-axis. So x-axis, y-axis. Right, if I wanted to plot f of the modulus of x, what we know happens here, just draw a new sketch, is everything stays the same for the positive x values and it flips. So I've got -12, this will be 6 and this will be -6. So this, and you get this kind of, well, bum shape. Okay, and then this is part B. This is part A. So for part C, everything below the x-axis is going to flip. So I might just do that on another piece of paper. Okay, so for part C, f of the modulus, f of x or modulus. So this, everything above will stay the same, and then everything below will flip. So this will be 6 minus 2 plus 12. Okay. Now let's look at one of the challenge questions. Here. Question 4 from exercise 2E on page 43. I think I better just get that opened up. Let me just see that, guys. So just turn to page 43. And it's question 4. Okay, so the first question asks you to sketch the graph of y equals kx. So we need to know, what does a over x squared look like? Okay, and you're told in the question, you're told a is positive. Okay, so let's think about what it looks like. Well, I know what x squared looks like. This is what x squared looks like. If it was just x squared, yeah, y equals x squared. If I was to look at 1 over x squared, i.e. the reciprocal of this, so at 0, 1 over 0 is not defined. So at 0, I'm going to have an asymptote here. And then 1 over these values, as these values get bigger, 1 over it will get smaller. So my graph is going to go like this. It will never reach 0 because 1 over x squared will never get to 0 for any value of x. And it's undefined for when x equals 0 because 1 over 0 is infinite. So this is why we've got an asymptote. And exactly the same would happen if x was negative. Yeah, I'd get an exactly symmetrical shape because if you think about it, 1 over negative 2 squared is the same as 1 over 2 squared, i.e. a quarter in each case. So that's the shape I get. Now it says, explain why it is not necessary to sketch the two modulus functions. Why is it? So let's think about what would happen. Let's look at this one. Y equals the modulus of the whole thing. Well, y equals the modulus of the whole thing means that everything that was negative becomes positive, but I've got no negative y values. So this is just the same as this sketch here. Yeah? And if we were to look at this, the modulus of k, the modulus of x, that means we ignore all the negative values for x, and this is split. Well, that's already the case. So this is quite a unique graph where each of these functions are exactly the same graph. So that's why you don't need to sketch them because they're exactly the same. Now it goes on to asking, what would you do if A was negative? Yeah? Okay, well, let's think about that. If A was negative, I'm just trying to find some more paper, guys. Give me a sec. Right, well, if A was negative, what would my graph look like? Well, if A was negative, x squared is always positive. All of my values that were positive are now going to become negative. So have a think to yourself what the graph's going to look like. Okay, so the graph is going to look like this. It's going to be a reflection of this graph about the x-axis. So this is what you get if k of x equals a over x squared and a is less than 0. A is negative. Because if a is negative, say for example if a was negative 1, if you were sketching this, for example, yeah, everything will be negative, all my values, because x squared is always positive. So it's the same shape but just making it all negative. Okay, so x and y. So we've got an asymptote here and an asymptote here. So this will tend towards the asymptote and this will tend. Right, next question. State with a reason whether the following statements are true or false. So statement 1. Is this true or false? Sorry, this is M. Right, so is the modulus of k of x the same as the modulus of m of x? Well, let's think what happens. What would the modulus of m of x look like? Well, the modulus of m of x means that all my negative values are flipped to become positive. So this is what my modulus of m of x looks like, which is exactly the same as k of x. So this is true. Yeah? Okay, part 2. Is this true or false? K of the modulus of x equals m of the modulus of x. Okay, well, let's think about what the modulus of x looks like. So I keep, this is my m graph, I keep everything for x the same, for positive x the same, and I reflect it about the y-axis. That's not the same as my original k of x. So no, this is false. Yeah. And the last question, part 3, and I'm going to end here and then you can do your work that's been set. Part 3 says m of x equals m of the modulus of x. Well, m of x is this, which we looked at first. This is m of x. And in the last question, we did m of the modulus of x. So this is true. So I wanted to go through that question because that was quite tricky. Okay, so now it's your turn. Have a go at the work that's been set for you, please. And good luck.